Hello, my name is Jack, and welcome to AI Research Considerations for Existential Safety. I am excited to introduce you to Andrew Critch. Andrew is a research scientist at the Center for Human Compatible AI at UC Berkeley, and is also the founder and president of the Berkeley Existential Risk initiative. His current research interests include logical uncertainty, open source game theory, and mitigating race dynamics between companies and nations in AI development. Prior to his work at Chai, Andrew worked in technical AI safety and financial trading. He completed a PhD in mathematics under Bernd Sturmfels at UC Berkeley. Today, Andrew will be discussing some arguments for technical research areas that he thinks will be relevant to existential risk, but which A, don't currently fall easily under the header safety or alignment, and B, could benefit from more existential risk-focused technical attention. We invite you to use the SwapCard platform during this session. On the right side panel, feel free to share your thoughts on the live discussion board and leave and upvote any questions for our speaker to answer at the end of the presentation. After the session, we invite you to use SwapCard to set up meetings with fellow conference attendees. Without further ado, welcome Andrew Critch.
Jack, thanks so much. I'm excited to be here. Everybody, thanks for coming. This is a great conference so far. I really enjoyed the talks and really enjoying the context that I get to come into. It's so much nicer not to have to define existential risk at the beginning of a talk when everybody already knows what it is. So thank you for that. In this talk, I would like to invite everybody to take note of the slide numbers or take screenshots of slides that you want to ask questions about, because I'm going to keep the slides up during Q&A, and I'm going to go pretty fast through the slides. The conference, I'm told, is a little bit behind schedule, so I don't want to push that. And so we're going to go fast. Here goes. And I guess while we're going fast, I'd like you to keep track of what my main goal for you is as a listener. Is that if you're interested in computer science, if you're interested in either doing computer science research or supporting computer science research that relates to existential risk from AI in any way, I'm hoping to expose you to a diversity of different tasks that human society needs to perform in order to be existentially safe with AI technology. And that's going to go beyond, it's going to include alignment, but in my opinion, it goes a little bit beyond alignment. And you probably heard some of that from Marcus's talk already. And I'm a big fan of their work, so you'll hear a little bit about that too. So here's my very short case for AI X risk. If you've ever studied robotics, you know, Jack, can you tell me if people can see my mouse while I'm presenting? My mouse visible?
Yes.
Great. So in robotics, everybody knows, you know, you've got your laboratory where you train and test things to stay in some kind of safe state while it operates, but then you deploy it in the real world and it gets outside of that comfort zone of states in which it knows how to operate and eventually ends up crashing or having some kind of an accident. So that lesson is important for the state of the entire world as well. If you think about Earth as a machine that's being operated by a large number of plants, animals, and humans, and increasingly AI technology, there's states of the Earth in which humans can exist, and I'm going to denote that by this human, this like fuzz here that denotes humans. And then there's many states of the Earth that would not allow human beings to exist. Like if you imagine if the Earth were suddenly like Mars, humans wouldn't be on it. Or if the Earth were a random configuration of atoms, humans would not be in that configuration. It would just be lots of dots and specks. So it's important to realize that most states that the Earth could possibly be in are states where human beings simply do not exist. And as a result, most ways we could set the world in motion under the control of an automated system will result in the world ending up in states where humans don't exist. So we have to do this kind of alignment work to sort of keep the global, not just individual machines aligned with human values, but the global state of the Earth aligned with this narrow pathway that we need to take the Earth through in state space so that it remains in a state where human beings exist. So I'm going to start by talking about the assistance relationship that we want AI technology to have to humans. You can think of a human as having an intention. This could be a human institution as well. It doesn't have to be a single human, but it's something with a coherent intention. And what we want is for AI technology to assist the human or human stakeholder institution in having the impact that they want. So the impact of the AI needs to match the intentions of the human. And some people call this an assistance game because there's two players in the game. Some people call it impact alignment because you have to align the impact of the AI with the intent of the human. So lots of different names for it, but that's the situation. And one approach to this problem is to sort of break it down into a subproblem where we think about what's the intention of the AI. Is the AI trying to do something? Can we design it in a way that it has an intention that matches the human's intention? And some people call it intent alignment. And if you can think about the machine's intentions, you can also wonder, is the human able to really understand what the machine is thinking? Can the human interpret the thoughts of the machine, or are its actions legible to the human? So you can think intent alignment is about making sure that the human's intentions are successfully transferred into the machine, whereas legibility or interpretability work in machine learning is about making sure the machine's intentions are understood by the human, so that, for example, the human can correct the machine if its intentions are off course, or the human can decide whether or not the machine is ready to be deployed based on whether its intentions seem competent. So that's interpretability or legibility. And then you can also ask, okay, if you have a machine whose intentions are well aligned with those of a human, and maybe they're well understood by the human as well, is the machine competent to safely and robustly execute on those intentions? So when you hear people talk about AI safety, most work in the field of artificial intelligence that's carried out under the heading safety is about making sure that the machine can really safely operate and not crash in new situations. So you can imagine decomposing this impact alignment problem into an intent alignment problem followed by a safety or robustness problem with an interpretability legibility check in the middle to help understand what's going on inside. And each of those perspectives gives rise to a whole different set of technical problems and research questions that people interested in existential risk end up working on. So I'm not going to go over all of these papers. My slides, Jack, I think it has the ability to send out the link to my slides to everybody. So you can just open these up and click on the links or search Google Scholar for any of these paper titles, screenshot them if you want. I'm going to zoom through them. But here are some papers and books about what I would consider the assistance problem, where we define success for an AI system in terms of whether it achieves what humans want. And here's some more work coming out of the Center for Human Compatible AI and Interact at Berkeley. These are both Berkeley research groups, so we work closely together. And we've also got people at DeepMind and OpenAI working on what I would consider impact alignment solutions. And I mentioned this last one by Paul. You'll see Paul's presenting right after me, so don't miss his talk. And this is a really interesting work because it's very much you can view it as an intersection between impact alignment and intent alignment, which is something Paul's written about extensively. You can read these blog posts that he's written, and the previous, I'll flip back a slide. This work here works by figuring out the human's intention and then trying to get a little sprite here to perform a backflip after a lot of positive and negative feedback inputs from human observers watching it trying to do a backflip. There are a couple of more pieces of work that you could consider under the intent alignment header. We have Rohan is also presenting today, talking about how you can infer the preferences of humans by just looking at the present state of the world as something that humans have worked towards. And Anka Dragon at Berkeley has a lot of work on intent inference or preference inference in robotics. So instead of a bunch of papers, here's a video I would highly recommend anyone to watch. Her work's really fascinating. And now moving on to interpretability, I direct you to the work of Chris Olah and Cynthia Rudin. They both got really fascinating approaches to how to make machine learning systems more understandable to humans. So we can look inside and say, that's a bad thought. Don't think that thought. Or that doesn't seem like it's going to work in the wild. We're not ready to deploy. And their approaches are counterposed. Chris Ola's approach is to look at something very complex like a neural net and try to understand how it works. Cynthia's approach is to try and make something understandable from the get-go. And you can see from the title of her paper that these are complementary approaches. And now moving on to safety and robustness, I would direct you to the work of Dario Amodei at Google Brain and OpenAI. He has this paper with a few other co-authors, including Chris and Paul, on concrete problems in AI safety that was really popular in 2016. As you can see, it's got a lot of citations, and it really helped open up the conversation about risks from AI in any context. Even as something as simple as a car crash became easier to talk about after this paper came out. And I'd also direct you to Jaime Fissak's work. He's now a professor at Princeton via Berkeley, and he's got what I think is going to be pretty transformative approach to how robotic systems and systems that operate in high-dimensional state spaces can remain safe while they learn. So, when we deploy AI systems in the real world, they're going to have to adapt to the real world while being safe during the adaptation process. And Jaime's work really hones in on that issue. Also, David Kruger is a longtime X-risk enthusiast / pessimist, depending on how you want to label. And he's got work on similar problems involving the change of environment that a system faces from training to testing or from testing to deployment. So there's all these different areas that people are thinking about. And the first thing I want you to take from this is, hey, there's people to work with. There's things to do. If you're interested in X-risk, if any of these topics interest you, reach out to these people and their co-authors and try to get involved in working with them, whether it's on the computer science front or if you have questions about policy that might need input on a technical side. And as these areas progress, what's next is that I think we're going to start looking at, as Marcus mentioned in his talk as well, we're going to look at interactions between hybrid human AI teams or institutions, where at first, like with calculators, machines are just helping us and we're still interacting with each other a lot. But as you can see with social media, technology is becoming interposed in our interactions such that some of the interaction you could say is being carried out by the machines. And eventually, the more our economy allows us to automate tasks, the more economic activities AI capabilities allow us to automate, we could start feeling like we're really delegating responsibilities to AI systems, almost like they're our personal assistants. And as that happens, we might get to a point where you can delegate the operation of an entire company to AI systems. So we'd have something like AI CEOs or AI government agencies. And when we're delegating that much responsibility to AI systems, you can imagine situations where humans just get left out of the picture eventually. And if you ask how could that happen, the answer is many, 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 many ways. I don't want to limit your imagination to one story for how humans could not exist. There are just so many states the world could be in that don't have humans. Any of them, except for the small, tiny number of states that you can imagine that do have humans, are states in which humans are extinct. That said, people like stories, so I'm going to try and categorize some of these states into different story categories involving conflict and cooperation. Starting with conflict, obviously, if you've watched movies where AIs go to war with each other, we can have a destructive outcome where a lot of humans die as collateral damage in a war between AI systems, or AI systems that have been designated to kill humans. Thankfully, we have people working to prohibit the design and construction of lethal autonomous weapons. That is, weapons that are allowed to autonomously decide to kill humans. And I think more work on that front is definitely helpful to reducing existential risk. And another thing you can do is try to complement AI's destructive capabilities with cooperative capabilities. So if AI technology is enabling competing states to cooperate better, they might have less reason to go to war. And thankfully, we have people from FHI and Oxford working with DeepMind to try and pioneer this field of cooperative AI. It's really building on types of thinking that's already been done in economics, multi-agent systems, game theory, social choice, human-machine interaction, et cetera. But as an objective, it's something we can all work together and make an important. We can make it an important vision for AI as a field to just help make the whole world more cooperative. And one way we can make things more cooperative is we can make systems and institutions more mutually transparent. If you look at the work of Joe Halpern, he's got pretty fundamental findings in game theory about how systems or agents that are somewhat or completely mutually transparent are able to achieve more socially cooperative outcomes. And so I focus a lot on that in my research. Sometimes I use logic to study what happens when systems reason about each other and whether or not they can use that reasoning to achieve cooperation. And moving further up the causal chain from cooperation to mutual transparency, I just want to make a second plug for these same researchers, Chris Ohl and Cynthia Rudin, because interpretability doesn't just help you interpret your AI system, it can help you interpret a competitor's AI system if they open it up to you. And that can make teams more mutually transparent to each other. If my AI system is inspectable to you and yours inspectable to me, if they're interpretable during that inspection, then suddenly we can gain a lot of trust in each other. Another area that I think is upstream of X-risk is fairness. And unfortunately, I don't have super X-risk oriented researchers that I can point to who are working on fairness right now. So this is something, if you want to show up and be really X-risk oriented and working in the field of ML fairness, you'll definitely get an applause from me, because I think there's a lot of reasons why fairness, it's kind of unfair, right? For someone to build an AI system that destroys the world while you weren't there, right? So it's a tremendous power imbalance between powerful people who can build AI systems and technologies powerful enough to kill all humans, and then the rest of the humans who get killed. And I think work to make technology more fair in how it's deployed and used is definitely progress on limiting the acceptability of taking an existential risk with the rest of the world just because you and your friends that you work with think that you're doing a good thing. So I would definitely encourage more work in fairness. And if we are really successful in things like fairness, mutual transparency, and legibility to the point of really getting a cooperative dynamic going in the way the world uses AI technology, if we achieve that, it's possible that the AI technology cooperates so well that the entire economy can be automated and humans get left in the dust. I've written a blog post about this. You can read more about it. But basically, here's a set of industries that could form a totally self-contained production loop if we manage to use AI to automate all companies in those sectors. So cooperation itself has some ways of getting out of hand if we delegate a lot of cooperative behavior to AI systems, and then they don't end up retaining that safe state for the Earth in which humans can exist. And then there are more complex processes that are neither cooperation nor conflict. And I think it's an open research area to identify and categorize those. So I'm not going to try and taxonomize them here. Instead, I just want to say that I think if you think of the field of all AI researchers, some AI researchers are going to turn out to be pivotal. They're going to be at companies or government projects or wherever you can imagine really transformative AI technology being developed. These researchers are going to have a say over how it's used. And I think one of the most robustly valuable things we can do to reduce existential risk is to think about, which and how many AI researchers are what I'd call X-conscious or existentially conscious. You have environmentally conscious as an important problem, important perspective for humans to have. And I'd like to expand that to just being existentially conscious and think, how many and which AI researchers are existentially conscious, and work on expanding that set, because the more AI researchers are existentially conscious, the higher fraction of those pivotal researchers will be existentially conscious. And if you can screenshot this, I'm not going to go into it, but here's my super rough back of the envelope calculation for how expanding the number of existentially conscious AI researchers is linearly helpful to reducing existential risk. I don't know how helpful it is. I don't know if you get massive increasing returns to just getting a few existentially conscious researchers, or if actually you need all of the AI researchers to be existentially conscious in order to have full existential safety. I really don't know. I just put these plots here to signal how much I don't know. But it does seem right to me that whatever way you draw it, more existentially conscious AI researchers is good. And it goes from 0 to 1 in terms of risk to safety as the percentage of existentially conscious researchers expands. So if you are interested in if you're existentially conscious and you're interested in AI research, that could be pertinent to existential safety, I would say don't stress too much about which of these areas you work on. If any of these topics excite you, or you feel like you have insight that you can contribute to these topics, just dive in and get into a good PhD program, or if you're already a faculty member, just reach out to colleagues and start collaborating with them. And I don't think it seems way more important to me to get involved in AI research and maintain your interest in existential safety as it relates to your research than it is to find right away the highest impact AI research that you can do. You'll get there with time once you have enough experience under your belt. So let's just work to grow this set of people. For some reason, these cartoons just appeared backwards, but I don't know who's going to be pivotal. I just want to say I really like all these people here, and I'd like to see more of them. So thank you for your time, and I'll go to questions now.
Thank you so much for that presentation. Cool. Yeah, we have, there's a pretty popular question. What would X-risk oriented fairness research look like?
Got it. So let's go back to my fairness slide. Here's a bunch of papers that I think are important to existential safety, even though the authors weren't necessarily targeting existential safety as their purpose. I think successes in defining fairness, successes in clarifying the fact that there are many different conflicting notions of fairness is important, because eventually there's going to be a lot of debate over what powerful, you can already see in AI policy, there's a lot of debate over what powerful AI systems should do, including debates over what kinds of fairness we want to prioritize. And so you can imagine building AI systems that listen to that debate and take into account all of the perspectives and comes back with its own proposal. Hey, everybody, here's a proposal. It takes into account a lot of different beliefs. I call this negotiable reinforcement learning. If it's a reinforcement learning system, I have a paper on it. If you do take into account everybody's beliefs, the AI system could make a proposal that everybody likes. So that's an example area that I think is very underexplored. And these are all successes, I think, in just developing the concept of fairness in a way that I think will benefit the structure and integrity of society, which in turn then helps us work together and minimize X risk.
Cool. All right, that's actually all the time that we have for this session. Thank you so much for the presentation and for your time with us today. Thank you all for coming.
Thank you, Jack.